Okay, so yesterday when we talked about limits, we said there's actually 4 methods that you could do. So one was just straight plugging the number in. The other method was some kind of math, maybe a cancel, factor and a cancel to get rid of the problem. Then we had plug in close numbers, and we had analyze. Okay, so number 1. This example, I believe, is an algebraic example. So let's try to simplify this as much as we can and see what happens. So can you square that for me? How do you square binomials? What's a good idea when you're squaring binomials? To repeat it twice, right, and FOIL it completely out. So see what you can get on that. Okay, so that's what I got when I FOILed that out. That's good. Now what could we do? Is there anything we can simplify the 16s you're seeing? 16 minus 16, that could go. I'm just going to move those around, not a big deal. Okay, so this is what I'm at now. What's the next algebraic step? There's something else we could do. Can we GCF out? Do you see it? GCF. GCF out. Okay, and now that causes the problem to get canceled. And that was the whole goal. Obviously plugging in the 0, the problem was the divide by 0, so now that problem is gone. Okay, did you notice how I wrote the limit in front of it the whole time? Okay, now I'm actually ready to input the 0 in. So I wrote it until I'm ready to input the 0 in. So now if I input the 0, I get 0 plus 8, which is 8. Okay, so that limit piece is always there until you actually plug it in. Okay, number 2. Did you know that you actually can't do that? If you wanted to try 0 to the 0 on your calculator. So obviously can't do any plugging in. What method does anybody think that we should try? Any guesses? Do you think there's any algebra that I can do here? No. Okay, can't plug in, can't algebra. So should I analyze or close values? Close values. Okay, so I'm going to use these x values, 0.1, 0.01. Okay, because I'm getting closer and closer to 0, but I actually have to also get closer and closer to 0 from the other side of the number line. Do we know that the absolute value, do you remember what that meant? That it turns positive? So do I even need to do this? No. Because putting this in will be the same as putting that in, right? Because the absolute value will turn into that number anyway. Okay, so let's try that number. And and that number. See what you get on your calculator when you try doing that. And you have to come to some kind of definite conclusion. Does it do the same thing? Should we try even a smaller number?
What are we looking for exactly with these?
I'm looking to see a conclusion of what's happening to the output.
So like whether it's increasing.
Is it getting towards a certain exact value?
Oh, okay.
Can you see what the y value output is getting closer and closer and closer to? 1. The conclusion, right? As the x values got closer to 0, what was going on with the y values? They were getting closer to 1. Okay? So that's what the limit is doing. As you get closer to that, what's the y doing? Bless you. Okay, methods. By the way, you're probably not going to get too many straight plug-ins because that's just too easy. So this one, I can't straight plug in because I have a divide by 0. There's no algebra you can do. I don't see any factoring, foiling, nothing. Should we do a plug-in? Plug in something close to 5? Okay, I'm going to be picking 4.9 and then 4.99, getting closer to 5. But I also better do that on the other side. So 5.1, 5.01. Okay, let's break this all down, same as yesterday. So Maddie's row, I need you to plug in the 4.9, John's row 4.99, Xander's 5.1, and Valley's 5.01. See if we can get some results as you plug those numbers in. Shayna, do you have an output for 4.9? Negative what? 49? Jacob, 4.99?
Negative 499.
Isa, what do you got on the 5.1? What's that? 51. Zach, did you get a 5.01? Did you plug this one in?
Yeah, I got 501.
501. Okay, do you have a conclusion? Okay, I'm going to kind of map this out for you. I'm going to make you think visually here. Do you remember that this would have a vertical asymptote at 5? Do you remember that? Okay, so here I'm coming along the graph this way. So 4.9. Do you understand that the graph would be going like that? Right? Because look at it. It's going towards negative infinity, right? As the graph got closer to 5, your curve is shooting down. What's happening as I move this way? As I got closer to 5, it is shooting up to infinity. So as I got closer to 5, did I reach an exact certain value? No. So my conclusion is that there's no limit. These are not doing the same thing. One's going to infinity and one was going to negative infinity, so there's no limit on it. Okay, it has to have an exact same to make that conclusion. Okay, number 4. The method that we're going to use for this is analyzing. Okay, so I want you to think about that. Both of those numbers are going to get pretty big, right? Is one going to get a certain rate bigger than the other? This will be a bigger number, right? What's your conclusion if a bottom of a fraction is bigger? Do you remember the rule? 0. Okay, if the bottom of a fraction is bigger, your number gets to 0. Okay. What do we do with negative exponents? Remember, so if I did something just randomly like this, what did we do with that? Do you remember the rule with negative exponents? We moved it, right, and then positive. So we moved it on the part of its fraction, right? Okay, you remember that rule from your logs exponent unit? Okay, so now, if this is a negative infinity, I'm going to move it to the bottom. And then the 7, that could get moved because it had a negative exponent, so when I move it to the top, okay, now I'm going to say that the top number is bigger. So what is your conclusion thinking about math? When the top number gets bigger, your number will do what? It'll just get bigger. So if the top gets bigger, you'll just get bigger. Okay, I flipped to the next page and there's a little bit of room on the bottom, right? Okay, let's talk about this. What happens to a number that looks like this? Think about numbers that are close to 0. So 1/10, that's pretty small. That's a small number. It's pretty close to 0. What's the result of that? Just 10, right. What if I get even closer to 0, so 1/100? What do you think happens there? 100. Do you see a pattern? What if I get even closer to 0, 1/1000? Then that turns into 1,000. What will this eventually approach? Infinity. And it's positive, right? what if I make the bottom closer to 0 from negative numbers? So I'm going to give you the same examples. So now I'm just going negative a tenth, which would turn into negative 10. What would your conclusion be? If the bottom was getting smaller and smaller, then the number is getting bigger and bigger, but this one is negative. Okay? So think about the bottom of a fraction. If the bottom of the fraction gets bigger, your number gets smaller, closer to 0. Here, the bottom was getting smaller, it was getting closer to 0, so your number got bigger. Okay, so let's put that into play here. Okay, so we just talked about this. That will approach infinity, positive infinity. So that's me analyzing what the situation is. Now what? Look at it. Does something get bigger more so than something else? The bottom would get bigger on this. So the final answer would be 0. Okay, that's analyzing it. Okay, let's plug in the next one here. Okay, so now this is the same thing as thinking that number would approach infinity. And now what? This one's a little bit tricky. Okay, so this is the same rate, right? So what happens? What do you think? So this is going to be like, let's say 7 billion and 5. This would be 7 billion and 10. What would that divide to? 1. Yeah. 1. Do you understand that these values in this case are irrelevant, right? 7 billion and 5 and 7 billion and 10, right? The bigger this gets, this is just basically irrelevant. Okay? Does that make sense to you?
So what if the infinity wasn't a billion and it was like 10? It'd still be 1?
If what if the what?
If you weren't considering that number to be so large, anyways. You know?
But you're going to infinity, so you have to think big. Yeah. I mean, I just gave a random, right? That is basically 1. So it's always going to infinity, so you have to think the big picture. Okay. Last one. So thinking about what would happen if there was a 0 on the negative approach. Okay, so we understood from what we drew out that this would be a negative infinity. Does that kind of make sense to you? Okay, now this piece, what happens to negative fractions? Okay, negative exponents, you flip positive, right? Do you understand that I can't just move it to the bottom because it can't detach from its 4 and all that, like it's a number together? Okay, before we only had a monomial term, so we could do that. Okay, does that make sense to you what I did? Negative exponents, flip. Now, think about what would happen to that number. 1 over something really big turns into what? 0, basically, right? 1 over a big number. This basically zeroes out. It goes so close to 0, so my final answer would be 4/5. Okay? Okay, I made this sheet last year and everybody loved it. It's a conclusion of all the things in one spot. So if you need to look at something, this is where to do it. So we had plug in. Then we had eliminating with canceling, factoring. We had the methods of plugging in close. And then we had analyzing. So here's your 3 rules from your rational. If the top is bigger, you're going to get bigger. But you have to just make sure you're analyzing if it's positive infinity or negative. If the bottom bit gets bigger, 0. It doesn't matter if you're approaching 0 from the negative or positive because you're still going to a 0. If they're the same, okay, same rate, you're going to do a division. And now these conclusions, okay, so if you approach the bottom to 0, infinite, the bottom to 0, negative infinite. And then this doesn't matter if the bottom is positive or negative, that's just going to 0. So that's the summary of all that in one spot, okay?